So we are going to talk this week about sound energy, sound waves, how sound travels. So the first thing we need to know is that sound energy starts out as a vibration. So it's an energy made up of vibrations, but sound starts when it vibrates, when an object vibrates, it moves particles. So we go from a vibration, it's moving, and that turns into sound waves. With sound, we have several different things. So we know we have the waves, we've got volume of sound, we have pitch, and we have frequency that we're going to talk about. So, first of all, if we look at a sound wave, there are several parts of this sound wave that we need to know. So, the highest point of a sound wave is called the crest. So, up at the top, the highest point of your sound wave is the crest. The lowest point of your sound wave is called a trough. The way I like to tell friends to remember this is if you've ever seen animals on a farm eating or drinking out of a trough, it goes down. There's like a scoop and it goes down to hold something. So if you look at this, it almost looks like you could fill this up. This is a trough. The length between two crests or two troughs of a wave is called the wave length. That means how far is there between each wave. That becomes important. The amplitude is how high a wave is or how low a wave is. That also comes in hand and that becomes important. So if we look back here, when our vibrations are really slow, look at how long our wavelength is, how much space we have between crests or troughs. When vibrations are really slow and our wavelengths are really long, there's a lot of space in between them. It's low frequency and very low pitch. So that's when you get really low pitch sounds. But when our vibrations get really fast, you can see how short our wavelength is. So over here, our wavelength was this far apart. Over here, it's super close together. So the shorter your wavelength gets, the higher your pitch gets. Your frequency gets high, your pitch gets high. So slow vibrations, you have long wavelengths and low pitch. Fast vibrations, you have short wavelengths and really high pitch. Now when we come over here to amplitude, the higher our amplitude gets, when it gets really high, and we go really high and really low, that's when we get really loud noises. But when we have really low amplitudes, you can see how short our amplitudes are down here on this wave. We have super soft noises. So, high amplitude, loud noise. High pitch is a really short wavelength, and those vibrations are fast. Low amplitude, we get a really soft noise. And when we have low pitch, we have really long wavelengths.